Are you ready for some piecewise functions? Oh yeah! What do domain and range represent on a functions graph? Well, domain is like your x values, it's your left and right. Okay, range is your y values, the up and down. So, a piecewise function is a function that's a combination of one or more functions. Okay. The rule for a piecewise function is different for different parts or pieces, piecewise, of the domain. A piecewise function that is constant for each interval of its domain is called a step function. Fun! Alright, so look at, they give you a set of equations and they're saying, alright, so f of x, remember that's the same as y, they're saying f of x equals negative 5 if f is less than or equal to 0. But if f is between 0 and less than or equal to 3, y equals 4. So it shows you different equations to use for different intervals of x. So they're telling us on these first problems, eventually we're going to be graphing these, and oh, will it be fun. But here, they want us to just evaluate the piecewise function for x equals negative 2 and x equals negative 5. So x equals negative 2 would fall into this equation, right? Because negative 2 is less than or equal to 0. So we would say f of the number we're using, negative 2, equals, and it's just negative 5. That's pretty darn easy. Now, it's pretty typical that you would have like an equation there to solve where you're substituting in x, but they're giving us a nice, easy one to get started. Let's see for positive 5. Well, that would fall into this category, right? Because positive 5 is greater than 3. So we'll say f of 5 equals, and that one was 12. It's almost too easy for these guys. All right, same numbers, negative 2 and 5. So f of negative 2, and we need to see which equation does this belong with. Well, negative 2 is less than 5, so we're going to use this equation. If x is less than 5, we're going to say 3x plus 4. And remember, we're substituting these numbers in for x. Oh, it says g of x, not f of x. It's all the same. Well, let's be proper. You know me. I'm so proper. So we're substituting in this equation for x. 3x, negative 2, plus 4. 3 times negative 2 is negative 6, plus 4 is negative 2. So g of negative 2 is negative 2. Fun. Now we're going to try it for positive 5. Well, positive 5 would fall into the second equation because that's greater than or equal to 5. So we'll say g of 5 equals, and we're going to use this equation, x squared minus 3. So 5 squared minus 3. 5 squared is 25, minus 3 is 22. So g of 5 equals 22. That was fun. We should probably dial it up a little bit. Oh my gosh, graphing it! So, I kind of like to think of these as like breaks in the graph. Kind of like you're folding over a sheet of paper, covering the part you don't want. So I personally like to draw like dashed lines, dotted lines, to show where the graph is going to change over. You don't need to do that, but to me that's like super helpful. So if we look here, it says, well, f of x equals negative 4 if x is less than 2. So if you had the line x equals 2, that would be a vertical line at 2. So I like to put this dotted line there. And we're going to have a different line on the left side of that and on the right side of that. So then we look and we're like, oh, okay, well, if x is less than 2, aka to the left of 2, we're going to be graphing the line y equals negative 4, which is just a flat line at negative 4. It would go on forever to the left, great, and we'll come back to that. Now, as soon as it hits 2, it's greater than or equal to 2, we're going over to this new equation, which is y equals positive 4. So it's going to jump up to positive 4. That's it. Now, what if it's exactly 2? which one would it belong to? Well, you go with the equal one, the greater than or equal to, which is this positive 2. So how we show that is if it's greater than or equal to 2, we're going to put a solid dot there, which means this one we would put an open dot on. That's showing like as soon as you hit that 2, it doesn't include this blue line here. It jumps up to the green line once it's at 2. And again, this dotted line, unnecessary. You don't need to put that on there. I just find it helpful to kind of divide up the graph into sections in my brain. So let's try this one. Now you'll see we have breaks at -3, 2, and 6. So -3 is here, +2 is here, and 6 is here. And I'm getting these numbers from the right side here. So this is between -3 and 2, from 2 to 6, from beyond 6. So when it is between -3 and 2, and neither one of those has the or equal to, so I'm going to put open dots on the end of this line. We're going to be at +5. Whoop. And again, that's going to have open dots on both ends, because those points wouldn't be included. That goes all the way to 1 point, as soon as it hits 2, it's somewhere else, different line. So between 2 to 6, we're going to be at +9. So I'll do that one in black. We're at +9. Now the 2 has the or equal to, so that would get a solid dot on that end of the 2. But 6 is just less than, so it wouldn't include that, so that would be an open dot there. And then we're in that last section. Once you hit greater than or equal to 6, it's going to go down to -3. So that would be down here, 1, 2, 3. And that's got the or equal to, so it would have a solid dot, meaning that point is included in that line. That's it. Now it doesn't say anything about once it's less than -3, and that's okay. That's the only section of graph they needed us to graph. This is what we were just doing. But now we have linear graphs. So if you look at this first one on C, our breaking line is at -2. So I'm drawing a dashed line at -2. But I'm a rebel. -2. So sometimes it is helpful to, like, you could just draw both lines and then you kind of erase the parts that you don't need. That can be helpful for some. Some don't need to do that. But if we are less than -2, to the left of this line, we're going to be graphing the line y equals x plus 4. Now, if you remember from your old Algebra 1 days, you're graphing in slope-intercept form. You start with the y-intercept, which in this case is 4. That would be your first dot. And then your slope is 1, so that means you go up 1, right 1, up 1, right 1, up 1, right 1. And you can just draw your straight line through it. But we only want to include the part of this line, goes on forever in both directions. We only want to include the part that is to the left of -2. So we kind of got to backtrack it a little bit. We're going to go down and left, down and left, down and left. We only want to include the section to the left of that -2. Now, it's just less than, so that would get an open dot. So we're going to erase all the stuff to the right of that -2, because that wouldn't be included in this piece. As soon as we hit the -2, we're graphing this line. Y equals -1/2 x. Now that has a y-intercept of 0, and the slope is -1/2, which means down 1, right 2, down 1, right 2, down 1, right 2. So we want to include every part of this line that is to the right of our dividing line of x equals -2. So if I wanted to backtrack, I could go up 1, left 2. And this one had the or equal to. So we're going to put a solid dot on the end of that. And sometimes they don't even put the solid dot. They'll just have the line there, but they'll show you the open dot for sure, showing that that point is not included. All right, and then D. So we have a couple dividing lines. We have -3 we have positive 1. So we have 3 chunks of graph we're going to graph here. To the left of negative 3, less than negative 3, we're graphing this line, y equals 3x plus 8. That would start at 8, and then the slope is 3, so you'd go up 3, right 1. But we only want the part to the left over here. So we're going to have to backtrack. We're going to go down 3, left 1, down 3, left 1. Down 3, left 1 would be there. Down 3, left 1. Down 3, left 1. Down 3, left 1. So we're only including those points in that left chunk. Let me see if I can erase these without jacking up the whole graph. All right. That one had the or equal to, so we're going to put a solid dot on the end of it. That part done. Check! The middle zone between negative 3 and 1, we're graphing the line y equals negative 2x. Has a y-intercept of 0. The slope is negative 2, so we'd go down 2, right 1. Great, we've hit the end of that. We could backtrack. We could go up 2, left 1, up 2, left 1, up 2, left 1. So here would be our line for the middle chunk. And neither one of those had the or equal to, so it would get open dots on both ends of that, meaning those points are not included once it gets to that part of the graph. And then the last chunk, once you hit 1 and greater than 1, we're graphing y equals x minus 3. That would start at negative 3 ordinarily, and then your slope's 1, so you'd go up 1, right 1. And we're only graphing the part to the right of that dividing line here. Now, they just so happen to share that point. If you look, it was an open dot for the middle chunk. Now it's going to be a closed dot. So it would be on that point either way. That's just a wild coincidence on that. Pretty wild. What else we got? Writing piecewise functions. Okay. Let me see how many. Oh, and that's it. Oh, man. And then you got a good joke worksheet today, dude. Good joke worksheet today. They already graphed it for us. We have to write the piecewise function. If you look here, so we'll say f of x equals, and then we have 2 chunks of graph. We have a chunk for our dividing line is at 2. So it'll be like x is less than 2, x is greater than 2. Now one of these has to have the or equal to. If you look which one has the solid dot, that would be this one up here. So that would represent greater than or equal to 2. That's the hard part. So what's the deal when it is less than 2? Well, when it's less than 2, our y is at negative 1, 2, 3, 4. Boop. Negative 4. As soon as you hit 2, it jumps way up to positive 4. Done. That's it. That's it. Over here, ooh, a little tougher. So I see kind of our dividing zone here. Now, it's hard to be precise with this. I would guess, since these are marked by 2's, that that crosses at x equals 5. It might be 5.2. I don't know. But we're going to pretend like it's just 5. So we'll say f of x. We have 2 different parts of this graph. So there will be a part where it's less than 5 and a part where it's greater than 5. Now, they connect in the same place, which means one of these would be equal to, and we can't really tell which. So it honestly doesn't even matter, since they meet in the same place anyway. So let's just make the top one less than or equal to. So we need to figure out the equation for that line. There it is. So if we're looking here, I see that its y-intercept is at negative 3, so something x minus 3, and then we need to figure out the slope of this line. So for the slope, remember, you could take any 2 points and you could count the rise over run. So each of these markings it's going by 2. That's the scale. So this is going up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So the slope, we're going to, 5 over 4. That's this left line here. Now the right line is quite a bit tougher. because I guess we could figure out the slope. So our slope from this point to here is up 1 over 1, 2, 3. So our slope is 1/3. So we'll say 1/3 x. The y-intercept is oddly the most challenging part here. So we're going to have to take it back. So the slope's 1/3, so we're going to go down 1, left 3. 1, 2, 3. Down 1, left 3 would be here. Ooh. The y-intercept is going to be 1 and some change. 1 point something. I'm going to guess it's like 1.3 repeating. Let's call it 1.5. You could figure this out by putting it into point slope form and then backtracking it. That's far beyond where we need to go here. It's going to be pretty obvious what the slope and the y-intercept are for it. So I have 3 here that I'd like you to try. If you're watching this video at home, I would say pause it here, try them, and then check your work when you're done. I'm going to do them a little faster here myself, but go ahead and do that. Try it out. All right, we got a line at -1 on this one. Here we're at 2. And then here it's right at 0. Nice. All right, so the first line, when it's less than or equal to -1, we're at +4, which would be this, and it's got the or equal to, so that would be a solid dot. When it's greater than -1, we're at -2. And it's just greater than, so it would get an open dot. All right, second one, when it's less than 2, we're graphing y equals -3x. That has a y-intercept of 0, and then it's down 3, right 1, down 3, right 1. Or you could go up 3, left 1, up 3, left 1, up 3, left 1. And that was just less than 2, so that would be an open dot, not the or equal to's. Now to the right of that, we're graphing the line y equals x plus 3. That would start at 3. Let me change color here. And then the slope is 1, so you'd go up 1, right 1. We only want the part of this line that is to the right of 2, which would include these points here. And it's the or equal to, so it would be a solid dot there. All right, last one. So less than 0, it's going to have an open dot at the end of it, but we're graphing 1/4 x plus 3. That would start at 3. It would go up 1, right 4, but we only want the part to the left, so we're going to go down 1, left 4, down 1, left 4. Whoops, that's not 4, that's 4. And then down 1, left 4, so it would be something like this, open dot on the end. Now when it's greater than 0, we're graphing -2x plus 3. That would start at +3, which happens to be where the other one left off, so we'll fill in that dot. And then the slope's -2, so it'd be down 2 over 1. Look at that. We just graphed some serious piecewise functions.